Hello class, this is a video tutorial on reciprocal trigonometric identities. These are not to be confused with the inverse trigonometric ratios used to calculate missing angles. So I've given three examples here, and I've highlighted them in a different color to emphasize to you what the inverse of trig ratios are. Those are used to calculate missing angles. What I'm about to show you is not the same. These are instead the reciprocal of the trig ratios. So once again, really trying to emphasize, this is not the same as this. So the inverse or the reciprocal of cosine B is 1 on cosine B. And this has a special name. It's called the secant of B. The short form for this is sec of B. If we do the same process to sine of any angle A, this becomes cosecant of the same angle A. But in short for mathematics, when we write it down, it's just cosec A. And lastly, for tangent, if we take the reciprocal of this becomes cotangent of the same angle theta, which is cot of theta. Now it feels as if we have to remember three more things, but it's actually pretty simple to remember. And what I remember being taught, and what I'm teaching you now, is the third letter of each of these reciprocal identities will tell you what their originals were. So sec has the third letter C, so that relates to cos. Cosec has a third letter S, so that relates to sine. And cot has a third letter T, which relates to tangent. So I hope that assists you in memorizing these. More importantly though, these these reciprocal identities affect how the original ratios are arranged. So, for example, we're very familiar with SOHCAHTOA, and applying it to any triangle. Here's just one example. However, when we take the reciprocal of these ratios, we also take the reciprocal of the values that they have. So if sine theta is x over y, cosec theta, and remember cosec, third letter, is S, that relates to sine. Cosec of theta is now going to be y over z. Oh, not z, x. Sec of theta, third letter C, relates to cosine. This is now going to be y over z. And cot of theta, because it's x over z, is now going to be z over x. Because we know this, we can now utilize the reciprocal ratios in questions and problems that we might face. So let's get straight to it. I want you to write the correct listed ratios given here. So for example, if someone said, write for me sine of theta, well, sine of theta is opposite, 3.2, over the hypotenuse, 5.52. Let's do the same for these ratios. Here we go. Cosec of theta, the third letter is S, relates to sine of theta. Well, we actually have already written the sine of theta. Cosec of theta is just the reciprocal of that, so it's going to be 5.52 over 3.2. Sec theta relates to cosine or cos. Cos in this example, cos of theta in this example would be x over 5.52, which means sec of theta is the reciprocal of that, so 5.52 over x. Cotangent theta or cot theta relates to tan theta. And in case the previous example didn't make much sense, we'll do an example here. Tan theta from here is going to be 3.2 over x, which means cotangent or cot theta is the reciprocal of this ratio as well. So this is going to be x over 3.2. This is the exact same for if we found cot of 54 degrees, 35 minutes. This is going to be, cot, well, opposite over adjacent is tan of this angle. Cot of that angle is the reciprocal, so 3.2 over x. Cosec of this angle, well, cosec relates to sine, so it should normally be x over 5.52, but cosec is the reciprocal of that, so it's going to be 5.52 over x. And lastly, sec of that angle is normally adjacent over hypotenuse. So this time it's going to be the reciprocal, so 5.52 over 3.2. Let's do 3 more examples for this. So let's solve the following, solve for the value of the pronumeral in the following. Here we go. So in this case, we want to solve for x. Okay, so normally we don't have a reciprocal button. So what we can do instead is we treat this in terms of cosine. So sec, remember the third letter, relates to cosine. If we did cosine of 54, we took the reciprocal of this, which means we take the reciprocal of this one as well. So this is going to be 10 over x. We can solve this as per usual. So this is going to be x is equal to 10 over cos 54. And we can solve this in our calculator. 10 over cos 54. Whoops. Get rid of this. 10 over. There we are. 17.01. That's 2 decimal places. Same thing here. We have cosec of theta. We don't have a button for cosec of theta in our calculator. So instead we change this in terms of sine. Remember, third letter relates to sine of theta. So sine of theta is equal to, well, it's the reciprocal of this. So root 3 on 2. And now from here we can solve this. So theta is equal to root 3 on 2 inverse of sine. So sine inverse root 3 on 2. This gives us exactly 60 degrees. One last example here. Let's solve this for cot 45 equals x over 5. Well, we can do this as tan 45 is equal to, well, because cot is the reciprocal of tan, and we changed it to 10, we should change this as well to match the ratio. So this is going to be 5 on x, which means it's going to be x equals 5 on tan 45. So 5 on tan 45. Get rid of the decimal. It's equal to 5. So I hope that gave you an insight into utilizing the reciprocal trigonometric identities. Hope to see you in the next video. Best of luck.